Your body is a temple, but it's also a museum of natural history. Look closely and you'll see parts that aren't there because you need them, but because your animal ancestors did. No longer serving their previous function, but not costly enough to have disappeared, these remnants of our deep history only make sense within the framework of evolution by natural selection. With your arm on a flat surface, push your thumb against your pinky and tip your hand slightly up. If you see a raised band in the middle of your wrist, you've got a vestigial muscle in your forearm. That tendon you see connects to the palmaris longus, a muscle that around 10 to 15% of people are missing on one or both of their arms. It doesn't make them any weaker, though. There's no difference in grip strength. In fact, it's one of the first tendons that surgeons will take out so that they can use it in reconstructive and cosmetic surgeries. You can find the palmaris longus across mammal species, but it's most developed among those that use their forelimbs to move around. In primates, that means the muscle is longer in lemurs and monkeys and shorter in chimps, gorillas, and other apes that don't do a lot of scrambling through trees. It's not the only leftover muscle that we've got. Look at the three that are attached to our outer ear. We can't get much movement out of these muscles, especially compared to some of our mammal relatives who use them to locate the sources of sounds. Presumably, this would have been quite helpful for early nocturnal mammals. In humans, you can still detect the remnants of this adaptation with electrodes. In one study, researchers recorded a spike of activity in the ear muscle cells in response to a sudden sound. Not enough to move the ear, but detectable. And you can probably guess the location of the sound based on these results. It came from a speaker placed to the left of the study subjects. So this is their left ear subconsciously trying and failing to pivot toward the sound. You can see another futile effort by our vestigial body parts when you get goosebumps. When we're cold, tiny muscles attached to our body hairs contract, pulling the hair upright, which causes the surrounding skin to form a bump. For our furry mammal relatives, the raised hair increases the amount of space for insulation, helping them stay warm. Birds can do this too. You've probably seen a puffy pigeon on a cold day. Adrenaline is one of the hormones involved in the body's response to cold temperatures, and it's also part of the fight or flight response. So it helps some animals appear larger when they're threatened. And it may be why surprising and emotional turns in music can give some people goosebumps. And then there's our tail. At the end of our spine are a set of fused vertebrae. Some people have 3, some people have 5. We call it the tailbone. It now serves as an anchor for some pelvic muscles, but it's also what's left of our ancestors' tails. Every one of us actually had a tail at one point when the basic body plan is being laid out at around 4 weeks of gestation. Human embryos closely resemble embryos of other vertebrates, and that includes a tail with 10 to 12 developing vertebrae. In many other animals, it continues to develop into a proper tail, but in humans and other apes, the cells in the tail are programmed to die a few weeks after they appear. Very rarely, though, a mutation allows the ancestral blueprint to prevail, and a human baby will be born with a true vestigial tail. The most adorable vestigial behavior is the palmar grasp reflex, where infants up until they're about 6 months old have this incredible grasp on whatever you put in their hand. There's a similar reflex for their feet. I wanted to show you this great piece of footage from the 1930s where they demonstrated this behavior. These babies are only 1 month old, and you can see that their inner monkey can support their entire weight.